Welcome to this video lecture. We are going to discuss about resistance temperature detector. A resistance temperature detector, also known as resistance thermometer or RTD, is an electronic device used to determine the temperature by measuring the resistance of an electrical wire. This wire is referred to as a temperature sensor. If we want to measure temperature with high accuracy, an RTD is the ideal solution, as it has good linear characteristics over a wide range of temperatures. The resistance increases as the temperature of the sensor increases. The resistance versus temperature relationship is well known and is repeatable over time. An RTD is a passive device. It does not produce an output on its own. External electronic devices are used to measure the resistance of the sensor by passing a small electrical current through the sensor to generate a voltage. The variation of resistance of the metal with the variation of temperature is given as RT is equal to R0 into 1 plus T minus T0 plus beta into T minus T0 the whole square plus so on, where RT and R0 are the resistance values at T degrees Celsius and T0 degrees Celsius temperatures. Alpha and beta are the constants, depends on the metals. Working. In RTD devices, copper, nickel and platinum are widely used metals. These three metals are having different temperature variations with respect to the temperature variations. That is called resistance temperature characteristics. Construction. This is the construction of RTD. Here you can see connection head, terminal block, removable retainer, spring loaded mounting fitting, thermo well, RTD lead seal, RTD probe sheath, insulated leads packaged in magnesium oxide, then RTD sensing element subassembly. Types of RTD. In wire wound, RTD uses platinum wire wound around a ceramic or glass bobbin. The construction keeps the platinum wire loose and let it expand and contract freely with the change in temperature. This minimizes a long-term stress-induced resistance change but has very poor resistance to vibration and is primarily limited to lab use. In thin film, the bifilar winding is wound around the bobbin and then sealed with molten glass, ceramic cement or another high temperature non-conductive coating. This construction helps protect the wire from vibration, but it is prone to long-term stress-induced resistance change when the bobbin and platinum wire have different temperature coefficients of expansion. Wiring configurations. A two-wire configuration is the simplest but the least accurate configuration. This constructions result in lead wire resistance getting added to the element resistance. Two-wire RTDs are mostly used with short lead wires or where close accuracy is not required. Three-wire construction is most commonly used in industrial applications where the third wire provides a method for removing the average lead wire resistance from the sensor measurements. It works by measuring the resistance between 1 and 2 and subtracting the resistance between 2 and 3, which leaves just the resistance of the RTD bulb. This method assumes that wires 1, 2 and 3 are all having same resistance. True three-wire resistance measurement will effectively cancel lead wire resistance error even if all four wires are not the same. It is used primarily in the laboratory where close accuracy is required. This method assumes that wires 1, 2 and 3 are all the same resistance. The four-wire circuit is a true four-wire bridge which works using wires 1 and 4 to power the circuit and wires 2 and 3 to read. Thank you.